Hey, we've got another $3 calculator teardown. I believe that this one is even older than the last one I did. And if you take a look inside here with this little flashlight, this one actually looks like it's got Nixie tubes in there. You can kind of see in there, you can see the plates that make up all the digits. So I don't know what specific model this is because there is no identifying like markings or anything anywhere. And the two labels, I'm guessing there was two labels here, those are completely gone. It's missing its feet. So I don't know, I haven't even powered it on yet. This one requires an AC plug and it's got a three-pronged here, so I guess it was grounded. At some point you can kind of see like there's a board in there, what looks like to be a capacitor. Over here we just got like a little ribbon of wire. So yeah, I have no idea what this is. Nothing, no particular model or anything. I believe this is this is the power switch because I already opened out the contacts in the back to figure out which ones were for AC. This one, much like the other calculator I did, also has this K button here, which kind of latches down. It seems to get stuck at times, but I mean it works for the most part. Basic functions, again, 4-function calculator. Everything kind of like the other one. It's just a lot older. Up here on the top there appears to be another spot for a label, which is, I'm guessing, where the original model number, whatever it's called, used to be. So let's well, before we take it apart, let's turn it on. And what I'm gonna do is I'm gonna hook up an AC cord like this one here. I'm gonna use some alligator clips, which is kind of dangerous and you should probably not do as I say, not as I do. So don't be doing this at home if you're not too familiar with dealing with like mains power or anything. And I'm going to plug it in to these two right here on the sides, because those are the ones that apparently go to the internal transformer, which I'm guessing it's got to have one. And actually, it might be kind of hard to see, but there's a transformer in there. And then, like I said, this is the power switch. So let's hook that up and then we'll see if this even works, because I haven't even tested it out yet. I just recently got it. And I thought it'd be neat to do a teardown on this one and take a look. So let's hook that all up and let's see if it works. Alright, here we are all plugged in. As you can see, here I've got the AC mains coming in here. I've used the shroud from the alligator clips to kind of cover them up a bit. I'm not going to be moving this right now, so I'm trying to keep from shorting out anything. As I said before, it's dangerous. If you don't know what you're doing, don't be doing stuff like this. So here goes. We're going to hit the power switch. And we are getting nothing, absolutely nothing on the screen. Well, actually, I don't know if you saw that. There was like a little flash right there. Huh. I don't know. I don't think we have to let it warm up. I mean, oh, it's doing something. It's got an 8899 right there and then a little decimal. I guess it does have to warm up a little bit. I'm just going to barely tilt this up. You can see it right there. Let's see. Clear it. Ah, there it is. Okay, so I guess it did have to warm up. I'm not too familiar with Nixie tubes, so I have no idea. Let's see. Yeah, it's working. Cool. 8 times 3, 24. Yeah, it's working. Cool. Let's zoom in on those digits a little bit here. So you can kind of see what they look like. Here we are, pretty up close. So as you can see, definitely Nixie tubes. So yeah, it's working works pretty well. So yeah, I guess there's nothing wrong with it. Alright, well, I guess I'm not really going to bother doing a demo on it because it's kind of pointless. I mean, just basic 4-function calculator. So let's go ahead and open it up now. Okay, so not terribly difficult to open up. There's just 4 screws on the bottom, one on each corner pretty much. There's 2 right here on the power connector, but I don't know if I got to remove those. Maybe I don't think I do. Maybe I'll have to remove them if I want to get that board out or something. So after removing these 4, I think this should just come off. Yeah, there it goes. And much like the other one, there's a cartridge connector right there that leads from the bottom to the top side. It's probably easier if I tilt this over a little bit. Oh, wow, that's a pretty big tube in there. Let's see, trying to be careful here. There's a connector that apparently goes to the power switch right here. That just unplugs. It's kind of convenient that they did that, because trying to desolder stuff would have been kind of a pain. And this part here is a little more difficult. See, this should just slide out. There it goes. All right, so now we got the bottom and the top. And there's the tube right there. Oops, sorry. There's the tube. As you can see, it's pretty deep and it's pretty big. And then it's got two little neon bulbs right here to light up the negative sign and the overflow sign right there on the corners of the front panel. This again is just going to be a switch matrix. Not sure what kind of switches they're using on these here, but it might, I'm guessing it probably, oh, these are huge. So these are definitely bigger than the ones in the other calculator. Got a toggle switch right here. So maybe we'll take, it's got a few screws here holding it down, so maybe we'll take that off so we can take a look and see what kind of switches they're using there. Not much else on the top. It's got some sponge here, which, ooh, it's like, it's kind of crackly, probably because it's so old, it's not even like spongy anymore. So try not to damage that, we'll just keep it all intact. And now, the interesting bits. Holy crap. Those are some pretty interesting looking, they almost look like hybrids. This one here, look at that little bodge. It's kind of funky looking there. Got what looks like to be capacitors right here. There's another IC underneath there, as you can see. These, I have no idea what they are. They are labeled A1 through, oh, this one here too. This one's all labeled A5. So I don't know if they're some sort of IC that's just inside the ceramic there. I'm kind of, I don't know if I want to take those off or anything. It might get damaged. And there's the power transformer. We've got a, this might be for the output here, I'm not sure. For the, yeah, because there's the rectifier, so that would be part of the power supply for the output of the power supply. Got a fuse, got a few more caps down there. Looks like it's got several different voltages going on in there. Here's the input. Check out these wires they're using here for power. There's the one coming off of this connection here that looks like to be about, I don't know, maybe like 18 gauge or something like that. But then this other one over here looks like it's like, I don't know, maybe like 24 or something. It's super thin, and that's for the mains. I mean, this is not going to be drawing a whole lot of power, so maybe it's not a big deal, but it's just kind of weird that they're using two different sizes here. I mean, the 18 gauge looking stuff is on this connector here and to the board, and the rest is just the ones that are going to the connector here and then over to the board again. So I don't know why they decided to do that, but I mean, well, whatever, it works. We got a few markings right here that have different voltages. We got 220 up at the very top there, and then we got 75, 93. I can't tell if that's supposed to be a negative or, oh, -5, -26, -14. There's one labeled clock here, and then there's a ground. So I don't know, maybe we'll take a poke in there with the scope. Then we've also got a couple of transistors right here. This one's labeled SDC445, and I did a quick search on that just now, and I come up with nothing. And underneath there we got another one that says SDC345. So I don't know, maybe that's some sort of a regulator or something. Not sure. We could probably test it out. Maybe hook up a ground lead there and check the output. I'm guessing it's going to be probably like maybe like a 5-volt regulator or something for all the logic. This bodge down here appears to be a resistor. You got a diode, maybe what might be like a tantalum right there, and then another diode on this side. Don't know if there's anything else in there. Doesn't appear to be. I don't know if you can see in there, but yeah, it looks like that's just it. And then it's inside of this what looks like to be heat shrink or some sort of just a little rubber tubing or something. It's, I don't know, it's kind of thick, so I don't know, maybe it's not heat shrink. The tube is mounted on these sort of like metal clamps almost, but it's got this spongy stuff also, and that's not feeling all that great either. So I don't know, maybe we won't take that apart either because it might just completely fall apart. And we can see all the connections from one end of the tube go to that connector down there, and then there's like a few on this side, although not as many as there is on the other side, and those all go down to the board also on that. I think that might be soldered in because it doesn't look like it's removable. So again, we got a few screws there. Let's say we got 4 holding this in place. We'll remove that. We'll look at the bottom of the board, which is probably just going to be more traces. Well, I've removed the screws to take the board out, but before we take it out, I'm guessing these are the date codes for these. Look, 39th week of 71, first week of 72. There was one over here that had 70. Look, 43rd week of 70. And I don't know what's underneath that one. I can't really move this out of the way because of the way it's soldered in. But screws are removed now, so this should lift up. There we go. So more sponge underneath, and then the connectors right there, and that's the underside. Some of the sponge stuff is kind of like come off, and it's on the board there, but I mean it's not like corroded or anything, so it looks pretty good. There's this piece of wire right here just kind of dangling off to the side. I don't know what's going on with that. I didn't even notice it over the top. Oh, that's ground. So I'm guessing they just kind of had it there just touching the casing, because it's really not doing anything else other than that. So there's where the cables or the connector from the Nixie tubes are connected. Those all seem to go here to this IC, so I'm guessing that's going to be, and I can't read the numbers on it. It's like all gray, and let me see if I can get a better view on that. I don't know. I don't really want to remove this, and it's riveted onto the board, so don't really want to mess with that too much either. Let me see if I can look in there. Maybe if I get the little flashlight again and I can flash it in there, I might be able to see what numbers they are. Okay, I was able to look in there at that chip with the flashlight, and it had a symbol that looks like that. So I don't know if that's supposed to be Silicon Instruments or what it is. These were the numbers that were on it, but doing a search brought up nothing. So I don't know exactly what it is, but it looks like it might be kind of like used as to drive each segment in or each section of the display like in sequence, so that it only like lights up the digits that you want at a time, and then it's all like kind of like multiplexed in there. A bunch of the traces here from the Nixie tube go to that chip, so I'm pretty sure that's probably what it's doing. And then we've got like another little bundle of traces coming over this way here, and there's a total of 8 of these, so that kind of corresponds with the 8 digits that are up here. So or that could be the driver for each number, sort of like say for like 1, 2, 3 through 9. I actually haven't counted how many lines are going to this, but let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it looks like there's about 10 of those going to that, which, yeah, that would make sense, because you got your period, and then you've got a total of 9 digits, or I mean your 10 digits, so I guess, yeah, that sounds about right. So yeah, this one's probably driving the numbers, and then this one here is driving each individual section here. I think the branding on these is actually pretty interesting, because I'm guessing that's the brand is EA, and these are all labeled like EA 5001, EA 5013, 5014, but the funny thing is that no matter which direction you've got this facing, like whether it's like right side up or upside down, it's still going to say EA. So that's a pretty clever design there on the brand. I can kind of, if I turn this around here, I don't know if you'll be able to see it, but yeah, it might be kind of difficult to see, but the silicon is on the underside of these ceramic plates there. So, and it looks like it might be coated with something that's blue. So yeah, I really don't want to remove those, but that's where it's at. For the ribbon here that goes up to the switch matrix, looks like what they've done is they've just taken this like sort of like vinyl sheet or whatever it is, and then just kind of like melted these wires onto the back of it, because it's not sticky. So I mean, it's not like tape or anything, but all these wires are pretty permanently attached. So that kind of keeps this whole thing is in sort of like a like a ribbon shape, even though it's technically all these wires. It's not like a pre-made ribbon. So they just use that to kind of keep all these wires orderly. And another thing on the board here, going up to the switch matrix, we can see that there's the markings right there. It's got the X and then the Y contacts. Apparently the Y's go all the way up to Y7 from Y0, and then the X goes from X0 up to X3. And again, there's not a whole lot of buttons on that thing, so it really doesn't need a whole bunch of wires going up to that. Then we've got a few other ones here that say 26, 14, 14, ground. I'm guessing that's voltage, so like 26 volts, 14 volts. Although why the keyboard needs that much voltage, I don't know. but you know, I guess it's part of the way this thing's designed. Then here on the bottom we have K and we have C. And then there's 4 extra wires here that are apparently not being used for anything. So the K would correspond to that button that keeps it so that you can keep constantly multiplying, and then the C would be the clear. I don't see a... Oh, there's the CE right there, so that would be the clear entry. So yeah, basically everything's labeled here as to where it goes. Alright, let's take a look up at the switch matrix here. I've already removed the screws for this one, and now this just comes out. And it's pretty heavy by itself. I mean, these things are huge. A lot bigger than the other ones. One thing I kind of noticed here is that all these tracers on here on the bottom are kind of tarnished, or, you know, they're not completely corroded through or anything, but they've got like that green stuff all over them. But since it was working, I mean, that means that they haven't completely degraded to the point of being crap, so that would just kind of require like a little bit of cleaning or something to get it in shape again. Let's remove one of these and take a look. It looks like this one here should be just one section, and yeah, it looks like they're using 2 screws to hold down each section here, so each part has well, in the case of these here, they have four switches. This one only has the 3 here, and then 4, and then we got 2 for these big ones here. So let's undo those. Okay, these are undone. And they're pretty long screws, and as I was undoing them, I heard a couple things fall, and it's these nuts. So those are on the top side here, so that means that these buttons should just pop out, and they do. And then the nuts fit inside of those little cutouts for them right there. So that brings out the... Haha! Okay. This one, unlike the other one, is using reed switches. So that means that inside of here we've got magnets. So when you push the button down, it brings down the magnet to, you know, like a point, like somewhere like around here in the middle of the button, so that it can make contact. So yeah, they came up with all kinds of ways to make these things work back in the early 70s. And yeah, I stick this in here and I can feel it pull to one side. It's I mean, yeah, you're not going to be able to tell. I mean, it's a really weak magnet, but it's enough where, you know, you can kind of feel that it's there. So again, pretty interesting. You know, I thought they were going to be using some sort of contacts like they did on the other one with the little wedges that, you know, when you pushed it in, it would push up against it. But no, they were using a totally different type of switch. And what do we have here? We have another screw. The only reason I realized it was there was because I saw the nut on the bottom there. So we can actually open this up and see those magnets. Looks like the bottom comes off right there. Got those springs, and there's the magnet. It's like they're little donuts. So there it is. Those little magnets are the ones that make the reed switches function. And I thought they were just going to be like little square magnets or something like that, but no, they're just little rings. So the ring just kind of will slide over the magnet like that, and then when it gets to the point where it makes contact, oh, you can actually hear it. Let me put it up to the microphone and see if you can hear this. You can hear that when it clicks. Yeah, so they're pretty loud. I mean, I can hear them from this is like 1.5 feet away from where I'm standing, and I can hear it when it clicks. Oh yeah. I don't know if you'll be able to hear that on the video, but yeah, when you push down, you can definitely hear like a little bit of a click. You know, when it's just closed up and you're doing this, you can't really hear it because all you hear is the clack, 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 clack. But if you're just gentle enough, you can hear it when that switch clicks on. And this other one right here, it's got a sort of like a mechanical latch. But I wouldn't be surprised if there's like a magnet in there also to, you know, to make a contact on the reed switch. And it probably is because it looks exactly the same as all the other contacts do. So yeah, there's going to be a reed switch on that one again. But because it's got the latch, you know, it kind of holds the magnet at that point to where it makes contact. And that's the underside of the buttons here. So these magnets just kind of like fall inside of that little hole made for them, and then the spring goes on top like that. So that holds everything in place, and then we can put this cover back on. And it looks like it's meant to only go in like one direction, like this. So that fits in place. Alright, before we wrap it up, let's just poke around a little in a few little spots here. Particularly want to see what kind of frequency we're getting out of that clock signal there. That's, or the one that's labeled clock. So what I did is I just jumped it right here on the connector that's supposed to go to the switch. So I'm just going to plug it in. And again, you got to be careful with this kind of stuff. Oh, this time it seemed to come on like almost instantly. So I don't know why it took so long the first time around, unless there's something wrong with that switch and it just wasn't making good contact. So let's see here. We'll connect this to ground, and then we will touch the other one to that clock. And right now it's doing nothing. Does it only do something when we push a button? I guess not, but it says it's about 6.5 volts at that point there. So I don't know. Let's see what kind of voltage we're getting here at this, what appears to be a regulator. So that goes from there. We've got another point here. That one's giving us about almost 13. So I'm guessing that's probably supposed to be the one that's 14 volts or whatever. Actually, this one here says negative 14, so it's the same thing. So it's a little bit under. Don't really know why. It could be just because some of these components are old. Let's see what we got over here also. We've got a one that's labeled 220. Let's see what we're getting on that one. That's 222. Almost 222 and a half. I don't know why I still have this in a exit. There we go. So let's see. Then we have another one here that says 75. About 74. A little under, but it's not way off. 91. This one's supposed to be 93. This one here says 5. And yeah, about 5.2. 26. Negative 27. So, I mean, not too far off. Everything seems like it's working okay. There's one thing I didn't notice until afterwards, is that there's this button here that's got like 2 arrows. I have no idea what that does. Let's put some 8s here and let's... Okay. That's weird. I honestly have no idea what that's supposed to mean. Let's see if we push it and then push a few more buttons. Let's see if I guess it just turns off the display or something. It's like secret mode. You write something there and let's see. 0, 8. So then you can be like, you know, hide it, bring it back, hide it, bring it back. Whatever. Alright, let's check that clock pulse with the scope here, and we'll see what we get. Let's bring this down. Right now we have it set to 10 microsecond time base. It's just kind of sitting there. And let's touch it to clock. And there we go. Definitely something going on there. And it looks like it's kind of... See, I have it on DC right now, so it looks like it's kind of like swinging towards the negative side there. And let's see about how much that is. We've got... almost 14 volts right there. So I guess the multimeter was just kind of like averaging it out a bit or something. So let's see, let's put it on to AC. Let's take voltage off. Let's do delta time here, and let's increase this, and let's see what we're getting for 1 cycle here. Getting, looks like it's about 6 microseconds. So let's work that out on our calculator and see what kind of frequency that is. Alright, let's use our trusty calculator here. Let's see, we've got 1 divided by 0.000006. We get about 166.6, almost 166.7 kilohertz. And I don't know why it's put the negative sign up here, but it should be, yeah. So that's about 166 kilohertz that this is running at. I don't know what it's supposed to actually be, but I mean that's what we get. So I hope that was kind of interesting. As I said, I really don't want to like destroy any of the ICs in here or anything, because I kind of want to keep this one intact as well, because I really like old stuff like this, like Nixie tubes, and the VFDs in this calculator are pretty interesting too. So I kind of want to keep these around just for, you know, I guess nostalgia's sake or something. I really kind of like old technology. So again, hope you found this kind of interesting, and I'll see you guys next time.